So far, every standard potential we used assumed standard conditions, which means each solution was exactly 1 molar. But real cells are not 1 molar. Then concentration changes, the voltage shifts, and the Nernst equation tells us by how much. Lower copper 2 plus, which is the reactant, makes it easier to grab electrons, so the voltage goes higher. S copper 2 plus or more zinc 2 plus means a weaker push, so the voltage goes lower. Voltage follows the concentration. For a single electrode, where a metal ion takes electrons to become the metal, the Nernst equation is equals na standard minus I over N2 times the natural log of 1 over the metal ion concentration. Here A is the gas constant, P is the Faraday constant, E is the temperature in Kelvin, N is the number of electrons, and the last term is the concentration correction. For the whole cell, taking cathode minus anode, the Gaussian cell gives Na cell equals Na standard cell minus I over 2 times the natural log of zinc 2 plus over copper 2 plus. But 298 Kelvin, I over O becomes 0.059 and the equation becomes cell equals Na standard cell minus 0.059 over N times the log of zinc 2 plus over copper 2 plus. This is the form you actually use. The ratio is product over reactant. Lower copper 2 plus makes the ratio small, so Na cell goes up. Lower zinc 2 plus makes the ratio big, so Na cell goes down. Do not fear the log. Thus plug in the ratio, press log, multiply by 0.059 over N, and subtract from Na standard. For any reaction, A plus Bu gives C A plus D. That ratio is called the reaction quotient. Products on top, reactants below, each raised to its number. Both the general Nernst equation, one formula for every cell, is Na cell equals Na standard cell minus 0.059 over N times the log of the reaction quotient. Let us do an example. Magnesium plus 2 silver plus gives magnesium 2 plus 2 silver. Silver plus is 0.0001 molar, magnesium 2 plus is 0.130 molar, a standard cell is 3.17 volts, and N is 2. Bona cell equals 3.17 minus 0.059 over 2 times the log of 0.130 over 0.0001 squared. Working it out, that comes to 3.17 minus 0.21, which equals 2.96 volts. Now let the Gaussian cell run. As it runs, zinc 2 plus rises, copper 2 plus falls, and the voltage slowly drops. Then the voltage hits 0, that is equilibrium. Putting a cell equals 0 into the Nernst equation gives standard cell equals 0.059 over N times the log of the equilibrium constant. For the Gaussian cell, log of the equilibrium constant equals 1.1 times 2 over 0.059, which is about 37.3. So the equilibrium constant is about 2 times 10 to the power 37, a huge number, meaning the reaction goes almost to completion. Thanks for watching. Like and subscribe to Baidyati. Electrochemistry, last 12 chemistry in English.